Let's start with the first-generation jets, Gloster Meteor, the Allied jet pioneer. Britain's twin-engine interceptor became the backbone of NATO's early airspace defense, serving the RAF, Belgium, and the Netherlands. Twin Derwent engines and straight wings offered reliability over speed, a necessary compromise for pilots transitioning from propeller aircraft to the jet age. Despite a critical Mach limit of 0.82, the Meteor delivered NATO's first all-weather capability. In the frozen skies of Northern Europe, that reliability meant survival. De Havilland Vampire, the twin-boom fighter bomber that proved British aviation could be exported. Its unique airframe, twin booms keeping the jet pipe short, maximized thrust efficiency, and allowed operations from runways too short for the heavier Meteor. Italy and Norway received their first jets in Vampire livery. France built it under license as the Mistral. Subsonic, yes, but agile, dependable, and forgiving. The ideal trainer for a generation learning to fly at 500 miles per hour. De Havilland Venom. Evolution under pressure. As Soviet bombers grew faster, the Vampire's successor arrived with swept wings and a more powerful Ghost engine. Higher speeds, better altitude performance. But early jet metallurgy took its toll. Structural fatigue became the Venom's hidden enemy. It filled the gap between generations, a bridge toward the supersonic revolution already forming on drawing boards in California and Paris. Republic F-84 Thunderjet, the American workhorse. Under the Mutual Defense Assistance Program, the United States deployed F-84s to nearly every NATO member: France, Italy, Belgium, the Netherlands, Greece, Turkey. Stable, long-ranged, nuclear-capable. The Thunderjet couldn't dogfight a MiG-15, but that wasn't its mission. Loaded with a tactical nuclear weapon, requiring JATO bottles to claw into the sky from European runways, the F-84 was NATO's deterrent-made steel. If the Red Army crossed the Fulda Gap, these aircraft would respond with atomic fire. North American F-86 Sabre, the MiG killer. Swept wings, hydraulic controls. This was the fighter that could meet the Soviet threat on equal terms. But NATO's Sabre fleet tells a more complex story than the skies over Korea. Canada built the finest variants, powered by indigenous Orenda engines, delivering superior climb rates to American J-47 models. 12 Canadian squadrons deployed to Europe as No. 1 Air Division, providing elite air superiority cover. Italy's Fiat assembled radar-equipped F-86Ks for all-weather interception. The Sabre became NATO's sword, and proof that American designs could be improved by Allied engineering. Dassault Ouragan, France's declaration of independence. Marcel Dassault's first jet to reach mass production was technologically conservative. A straight-wing design similar to the F-84, but strategically revolutionary. France would not rely solely on American or British imports. The Ouragan proved French industry could relearn high-speed aerodynamics and precision manufacturing. It was a stepping stone, yes. But every journey toward autonomy begins with a single step: supersonic interceptors. The mid-1950s brought a new threat: high-altitude Soviet bombers carrying thermonuclear weapons. NATO's response demanded Mach 2 speeds, rapid climb rates, and pilots willing to push the edge of physics. Lockheed F-104 Starfighter, the Widowmaker. Kelly Johnson's missile with a man in it became the most controversial aircraft in NATO history. Designed as a lightweight day fighter, it was remarketed to Europe as an all-weather nuclear striker. The deal of the century saw West Germany, the Netherlands, Belgium, and Italy select the F-104G in a procurement program later tainted by bribery scandals. The transition was catastrophic. The Luftwaffe lost 292 aircraft, 116 pilots killed. But operationally, the Starfighter delivered exactly what NATO needed: a Mach 2 platform capable of delivering a B-43 nuclear bomb into Soviet airspace. The Warsaw Pact could not ignore it. Italy's F-104S variant served until 2004, outliving every other starfighter by decades. Dassault Mystère 4, France's first transonic fighter. Swept wings and an ATAR engine allowed dives beyond the sound barrier, a symbolic and tactical breakthrough. Recognizing its quality, the United States purchased 223 Mystère IVAs using offshore procurement funds, effectively subsidizing French industry to strengthen NATO's posture. The aircraft saw combat at Suez. It proved that France could compete with American designs, and it paved the way for the Delta Wing revolution to come. Dassault Mirage III, the Delta Demon, Western Europe's first Mach 2 aircraft. The tailless Delta configuration offered low drag and structural simplicity, ideal for high-altitude interception. Belgium and Spain adopted it. The Mirage 3E added strike capability, transforming interceptor into multi-role weapon. It demanded long runways and precise handling, but it proved a fundamental truth. Europe could build world-class supersonic fighters without American blueprints. English Electric Lightning, Britain's supersonic rocket, vertically stacked Avon engines, a notched Delta Wing, a climb rate of 50,000 feet per minute, performance that would rival the F-15 Eagle decades later. The Lightning was designed for one mission: intercept Soviet Tu-95 bombers attacking Britain's V-bomber bases before they could launch nuclear retaliation. It was spectacular. It was fuel-critical. It was pure point defense, incapable of extended patrols or multi-role operations. But in its narrow domain, the Lightning was untouchable. It served until 1988, a testament to engineering brilliance constrained by Britain's shrinking defense budget. Hawker Hunter, the gentleman's fighter. Subsonic, yes, but revered as one of the finest handling aircraft ever built. 4 30mm Aden cannons gave it devastating firepower against ground targets. Exported to the Netherlands, Belgium, and Denmark, the Hunter proved that not every fighter needed Mach 2 capability. Some missions demanded reliability, precision, and grace. The Hunter delivered all three, serving in secondary roles into the 1990s. Century Series fighters. America's alphabet soup of supersonic designs filled specialized roles across the alliance. North American F-100 Super Sabre, the world's first fighter capable of supersonic speed in level flight. For NATO, the F-100D served as a tactical nuclear delivery platform, deployed to France, Denmark, and Turkey. But its legacy extends beyond strike missions. The F-100F two-seater pioneered the Wild Weasel mission, suppression of enemy air defenses, hunting radar-guided SAM sites, a tactic that would become central to every NATO air campaign for the next 50 years. Convair F-102 Delta Dagger, the pure Delta interceptor. Designed to destroy bombers with AM-4 Falcon missiles, the F-102 was exported to Greece and Turkey in limited numbers. Its only NATO combat occurred during the 1974 Cyprus invasion, when a Greek F-5 reportedly shot down a Turkish F-102. The irony was brutal: a missile-only interceptor, helpless against agile dogfighters. The lessons learned would reshape NATO fighter doctrine. Collaborative European projects. Rising development costs and the need for specialized capabilities drove Europe's first multinational consortiums. Fiat G91, GINA, NATO's first attempt at standardized procurement. The 1953 competition for a lightweight tactical strike fighter produced the G91, designed to operate from improvised grass strips after nuclear strikes destroyed main air bases. Italy and West Germany adopted it. The vision of alliance-wide standardization failed, but the G91 delivered decades of reliable close air support. Italy's twin-engine G91Y variant served into the 1990s. Seapacat Jaguar, Anglo-French cooperation under Cold War pressure. What began as a supersonic trainer became a potent low-level strike aircraft. Digital navigation systems, NAVWAS, allowed precision attacks in a single pass. Capable of delivering British WE-177 and French AN-52 tactical nuclear weapons, the Jaguar proved its worth during the Gulf War. Underpowered compared to contemporaries, perhaps, but effective where it mattered. Panavia Tornado, the swing-wing masterpiece. Britain, West Germany, and Italy formed Panavia to build the multi-role combat aircraft. Variable geometry wings allowed high-speed dash at low altitude. Terrain-following radar enabled automatic flight at 200 feet, in darkness, in weather, through the heart of Warsaw Pact air defenses. Its primary mission: runway denial using JP-233 submunitions and tactical nuclear strike. The UK developed a dedicated interceptor variant, the ADV, to patrol the Greenland-Iceland-UK gap, defending the North Atlantic from Soviet maritime bombers. Despite political delays, the Tornado became the ultimate expression of European industrial integration. Dassault Dornier Alpha Jet, the highway fighter. France and Germany collaborated on a trainer that became a frontline attack platform. German Alpha Jet, as were designed to operate from Autobahn strips during wartime dispersal, a flexible, survivable asset for the forward defense of West Germany. Belgium used them for training, dual-use efficiency in an era of constrained budgets. American multi-role giants. The Vietnam War reshaped American fighter design. Agility, multi-role capability, and reliability became non-negotiable. McDonnell Douglas F-4 Phantom II. The Rhino. Originally designed as a U.S. Navy fleet defender, the F-4 became NATO's benchmark multi-role fighter. Twin engines, powerful radar, massive payload capacity, air superiority, strike, reconnaissance, all in one sortie. Germany, Greece, Turkey, and Spain operated it extensively. Britain purchased F-4K and F-4M variants, re-engined with Rolls-Royce Spies for carrier operations, trading top speed for low-altitude thrust. The Phantom defined the 1970s and 80s. Northrop F-5 Freedom Fighter, the lightweight champion. Designed as a low-cost export fighter, the F-5 became critical for NATO's flanks. Norway, the Netherlands, Greece, Turkey, Spain, and Canada operated Freedom Fighters and Tiger IIs. Simple, reliable, high sortie rates from austere bases. Canada produced the CF-5 under license for Arctic operations. The F-5 proved that smaller allies could maintain credible air defense without breaking their budgets. General Dynamics F-16 Fighting Falcon. The Viper. The sale of the century saw Belgium, Denmark, the Netherlands, and Norway select the F-16 over the Mirage F-1 and Saab Viggen, launching the largest co-production program in history. Fly-by-wire controls. 9G maneuverability. A blended wing body that rewrote dogfighting tactics. Originally a day fighter, it evolved into an all-weather multi-role platform through continuous upgrades. The F-16 became the NATO standard, eventually operated by 11 member nations. Standardization achieved at last. McDonnell Douglas F-15 Eagle. Air superiority incarnate. Though operated exclusively by the USAF in Europe, the F-15's presence at Lakenheath and Bitburg guaranteed NATO air dominance. Twin engines. Unmatched radar capability. Zero losses in air-to-air combat. The ultimate insurance policy. McDonnell Douglas F/A-18 Hornet. The twin-engine solution. Canada, Spain, and Finland selected the Hornet for its robustness and role-switching capability. Twin engines provided safety over the Arctic and Atlantic. Carrier-grade landing gear allowed road base operations. Mid-mission role changes from air superiority to strike. Naval aviation technology applied to land warfare. Adaptable, dependable, effective. STOL revolution. The threat of nuclear strikes on fixed airbases drove a radical solution. Fighters that didn't need runways. Hawker Siddeley Harrier, the jump jet. Vectored thrust nozzles allowed vertical takeoff from forest clearings, car parks, even ships. In a nuclear-devastated Europe, the Harrier could operate from anywhere. Subsonic, yes, but survivable through dispersal. The Sea Harrier proved the concept in the Falklands, shooting down Argentine jets with sidewinders. British innovation solving the vulnerability problem. AV-8B Harrier II, the second generation. Anglo-American co-development produced composite wings, advanced avionics, and precision ground attack capability. The U.S. Marine Corps, RAF, Italian Navy, and Spanish Navy deployed Harrier IIs from light carriers and austere forward sights. Expeditionary power projection without supercarriers. Fourth-generation Euro canards. The end of the Cold War didn't end the need for air superiority. Europe's answer: unstable aerodynamics and canard delta wings. Eurofighter Typhoon, the agile giant. Britain, Germany, Italy, and Spain combined resources to counter the Su-27. Aerodynamically unstable for extreme maneuverability. EJ-200 engines enabling supercruise, supersonic flight without afterburner. Despite political delays, the Typhoon matured into a potent swing roll platform, carrying Meteor beyond visual range missiles and Storm Shadow cruise missiles. European strategic autonomy in fighter production. Dassault Rafale, the omnirole master. France withdrew from Eurofighter to pursue carrier capability. The result? A lighter, more versatile platform capable of air-to-air, ground strike, nuclear deterrence, and reconnaissance, all in one sortie. The Spectra electronic warfare suite provides active stealth by canceling radar signals, combat-proven in Afghanistan, Libya, and Mali. France's refusal to compromise sovereignty for collaboration vindicated. Saab JAS 39 Gripen. The Road Warrior. Sweden joined NATO in 2023, bringing the Gripen into the alliance. Designed to defeat a Soviet invasion through dispersed highway operations, the Gripen prioritizes maintainability by conscript mechanics and network-centric warfare. The Czech Republic and Hungary operate earlier variants. Sweden's advanced Gripen EF is entering service now. Nordic pragmatism, high capability at sustainable cost. Eastern integration. NATO's expansion brought Soviet hardware and indigenous projects into the alliance. Mikoyan MiG-29 Fulcrum. The Soviet interloper. Poland, Slovakia, Bulgaria, and unified Germany inherited MiG-29s after the Cold War. NATO finally gained operational access to Soviet fourth-generation aerodynamics. Germany retired its fleet quickly, selling them to Poland. Poland modernized them to NATO standards, IFF transponders, secure radios, operating them alongside F-16s. Most have now been donated to Ukraine or retired. The MiG-29's time in NATO was brief but revelatory. Aero L-159 Alka. Czech innovation. The advanced light combat aircraft evolved from the L-39 Albatros trainer, equipped with Western avionics, Honeywell iTech engine, Griffo radar, a subsonic light attack jet for close air support and border patrol. Proof that smaller nations could maintain indigenous aerospace capability within NATO standards. IAR-99 Shoam, Romania's Hawk, an advanced trainer and light attack aircraft modernized with Israeli avionics, capable of training F-16 pilots while retaining combat capability with laser-guided bombs and Python missiles. Indigenous production meeting alliance requirements. Fifth-generation dominators, stealth, sensor fusion, network-centric warfare. The future has arrived. Lockheed Martin F-35 Lightning II. The sensor shooter. 12 NATO nations have selected the F-35. Britain, Italy, Netherlands, Norway, Denmark, Belgium, Poland, Finland, Germany, and the Czech Republic. Very low observability makes it invisible to enemy radar. Sensor fusion transforms it into an airborne intelligence node, gathering data and distributing it to legacy fighters in real time. European nations manufacture key components. Center fuselages. Final assembly at Cameri. Despite cost overruns, the F-35 fulfills the 1950s dream. A single common fighter with shared logistics. Standardization. Finally achieved. Taycan, the Turkish Phoenix. After removal from the F-35 program, Turkey launched its own fifth-generation fighter. Twin GE F-110 engines. Indigenous avionics. The first prototype flew in early 2024. By 2026, advanced flight testing is underway. Turkey is developing a domestic engine, TAR motor, to eliminate dependency on foreign suppliers. Service entry targeted for 2028. NATO's second-largest military, proving it can produce homegrown stealth capability. Strategic independence through aerospace ambition.